So in looking at example 1 here, example 1 says, on the map, the center of the pyramid of the sun is 4 centimeters from the centimeter of the pyramid of the moon. Okay, what is the actual distance from the center of the pyramid of the sun to the center of the pyramid of the moon? Okay, if you look at the scale, though, in the picture that it says, what is the scale factor here? Look at the actual picture. It's right above. Right above example 1. What is the scale factor? Yes, sir. Okay, so again, it's 1 to 200. 1 goes in the numerator, 200 goes in the denominator. So that is your scale factor. So I'm going to put scale factor. Right? And again, that's from above. Okay, we know how far it is from the pyramid of the sun to the pyramid of the moon, based off the drawing. How many centimeters does it tell us it is? How many centimeters does it tell us it is? Okay, so it's 4 centimeters. We know that that is the distance. Now, we have to set up a proportion here. And we have to set up a proportion because we don't know how far the actual length is. Okay? Here is a key that is very, 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 very important. And if you were to take away one thing today, I want you to take away this. The numerator, the numbers in the numerator are always going to be the scale drawing or the scale model. The numbers in the denominator will always be the actual numbers from whatever the object is, whether it be the actual distance or the actual height and weight of something or the actual length and width of something. All right? Okay, so here again is the important part. When we set up our proportion, I'm going to draw our proportion. Proportion is just 2 ratios that are equivalent. When we set up this proportion, the numerator is going to be from the scale model or the scale drawing, and in this case, it's going to be 4. The question then becomes, what goes in the denominator? Well, the denominator is the actual length. Do we know the actual length that 4 centimeters represents? The answer is no. So we can put a variable there. And we can put the variable being just x. This is going to be equal, though, to your scale factor, which we already know. The scale factor is 1 over 200. From here, we just have to solve to find what the variable equals. So all we have to do, cross multiply. Okay, so we're going to cross multiply. Boom, boom. Ooh. All right, so when we cross multiply, that's going to be x times 1, which is just x, equals 4 times 200, which is 800. And that's going to be 800 meters. And now we have found the actual distance from the center of the pyramid of the sun to the center of the pyramid of the moon. An actual distance. Okay? So the actual distance from those 2 points is 800 meters. So that would be example 1. Okay? Now, example 2. Example 2 is finding the scale of a drawing. So trying to find the scale factor. Okay, it says the floral carpet, every few years, the Grand Place in Brussels, Belgium, is decorated with a large floral carpet made of begonias? Begonias? Yeah. Before making the carpet, the designers make detailed scale drawings. Suppose the floral carpet is supposed to be 40 meters wide. Okay, so let's write that down. 40 meters wide. I'm just going to put M for meters. A designer creates a scale drawing of the carpet that is 20 centimeters wide. Okay, so the scale drawing is 20 centimeters wide. And they want us to find what the drawing's scale is, or the scale factor of the drawing. This is very simple. What did I say always has to go in the numerator? So again, what we're going to do is we're going to put 20 in the numerator because that is the scale drawing. That's the size, that's the length of the scale drawing over 40, which is the actual length. Okay, so again, this is meters, this one's centimeters. All you have to do here is simplify now. When you're looking for the scale factor, you're going to simplify from here. Okay, so all you have to do is simplify 20 over 40. And what is that? Once you find the GCF, you find the GCF is 20. So you got to divide the top by 20, the bottom by 20, and you get this to be 1 over 2. And again, that's 1 centimeter equals 2 meters. That's how you find the scale factor. My next question would be, though, when you see a colon, so look right below example 2. It has scale with units. If you see 1 centimeter 1 centimeter colon 2 meters, what does that colon actually mean? So when you see that semicolon, it means that it is a ratio, and it can be written as a fraction. It can be written with the word 2 in between. It can be written with the semicolon. It does not matter. Example 3, the last example. So in example 3, you're going from finding a dimension of a scale model. Okay, so it says a model of a space shuttle has a scale of 1:52. If we were to write that as a fraction, again, how are we going to write that? Okay, so we would write it as 1 over 52. It then says that the space shuttle, the actual space shuttle, has a wingspan of 78 feet. It wants us to find the model's wingspan. So again, we are going to have to set up a proportion to find a missing variable. Okay, so again, set up the proportion. Line, equal sign, line. Okay, so remember, we said when we're figuring this out that it's going to equal the scale factor, so we can put this 1 over 52 here. Remember what I said. In the numerator has to be the scale drawing or the scale model. Okay? In this case, we do not know the scale model size. So again, we're going to have to put x. Because remember, this 78 here, it comes from the actual size. Okay, that's bad A, but it's actual size. All right, so again, the actual size goes in the denominator. From here, what you do is you then cross multiply. When you cross multiply, you get, let's see if I can move this up. You get 52x, because x times 52 is 52x, equals 78 times 1, which is just 78. You box. You bridge. You divide both sides by 52, because you're dividing both sides by the number that is with the variable. You get x over there. 78 divided by 52 is equal to 1.5. So it's equal to 1.5, okay? So that is what the length of the scale model is. The scale model is going to be 1.5. That's the wingspan of the scale model. Are there any questions on any of this so far? Any questions on any of this so far?